In this recording, we will be talking about the bounds for any set. Now, any set can have an upper bound or a lower bound or both. Okay, so there are two sort of bounds. So you have an upper bound, you have a lower bound. Let me just define for you what do we actually mean by lower bound. Lower bounds for any set. Now for any set A, for any set A belonging to the set of real numbers, okay, so a subset A of real numbers. Now a number L, say L stands for lower bound, such that L is less than or equal to A for all A belonging to the set A, then you call L the lower bound of the set A, the lower bound for the set A, okay, lower bound for the set A. So what do we actually mean by this? Now, if I give you a set, say A is an open set 5 to 8. So on the real line, what will this set look like? It will be the real line, positive side of the real line, and the numbers from, you can start with 0 and so on and so forth. Here say you have 4, here you have 5 till 8, and of course the real line moves on. So the set that we are talking about is the open set 5 to 8. Now open set 5 to 8. Now I assert that actually 4. Let me take 4. 4 is a lower bound of this set, is a lower bound of the open set 5 to 8. Why am I saying so? I'm saying so because 4 is less than or equal to all A belonging to the open set 5, 8. Okay, belonging to this open set 5 and 8. That is why 4 is a lower bound of A. In fact, anything lower than that would also be a lower bound if you think about it carefully. Now comes the concept of upper bound. So similarly, what do you think will be an upper bound of this set? Now upper bound for any set, U is said to be an upper bound of any set A, any real set A, when we have that U is greater than or equal to A for all A belonging to this set A. Okay, so that means if we take the same set, what do we have? We have that 9. I assert that 9 is an upper bound of the open set 5 to 8. Why? Because 9 is greater than or equal to A for all A belonging to this set 5 to 8. Okay, so that is why 9 is an upper bound. Other than 9 also you can have many other upper bounds, right? But 9 is an upper bound of this set in any case, for any set, for the set given to us. Now, so what we can define now, we are in a position to define some things. Let's define. What we can define now, if a set A admits at least an upper bound, at least an upper bound, then it is called bounded above. So when will we call a set bounded above? When it has an upper bound, bounded above. When it has an upper bound, you call it bounded above. And similarly, if a set admits at least, okay, you can have more, but at least one lower bound, okay, then it is called bounded below. Okay, so then it is called bounded below. Okay, and now most importantly, when do you call that a set is bounded? A set is called bounded when it has both, when it has a lower bound as well as an upper bound, then it is called bounded. So a bounded set essentially means that a set that is both bounded above as well as bounded below. Okay, these are the short forms, bounded above and bounded below. Then you call a set bounded. Okay, now for example, now if I give you an example, just think of a set of certain numbers, so 2, 3, 4, 5. What do you think? Is this set bounded? Yes, of course, it is a bounded set. This set is bounded. Why? Because it will have a lower bound as well as an upper bound. This set has a lower bound 2 and an upper bound 5, right? Now, if I give you a set, say minus infinity to 3, is that bounded? No, it's unbounded because it's unbounded from one side. It's unbounded. It does not have any lower bound. Therefore, it is unbounded. So, to be bounded, you need to have both the conditions getting satisfied. You need to have the set to be both bounded above as well as bounded below. Now, another example we can say, let's take a set 3, 4 union with the half closed, half open interval 5 to infinity. Now, this set will be again unbounded because it is bounded below, but it is not bounded above. It is only bounded below. That is why this will be unbounded set, because it is only bounded below and then it is going to infinity. Okay, so therefore it will be an unbounded set.